of curve. This is a magnitude of any object. Okay, therefore I can calculate, or I may use this f. Okay, 1 plus dx dy is if I wanted to base on the dy. Similarly, I can go for the parametric. I already shown you how to calculate the parametric as well. Okay, okay, can we go for one simple example for this? Okay, let me cover this example quickly. Okay, I worried the battery is okay, running out of the energy. Okay, in this case, okay, I'll choose one example. Okay, just say calculate the work, okay, of C. Where is this? 4x 3x y ds. I'm just saying ds, but I cannot simply leave it like that. Okay, calculate the ds. Let me give you the ds. What is ds here? Okay, but I need to give you the equation where the object is moving from. Okay, then you know what is the ds lah. Okay, in this particular case I'm choosing the simple one. Okay, 1 to the 2, and the equation is y equals to 2x. Wow, I might give up. Yeah, the equation. Actually, I wanted to give you more complex, but let you all to understand this process. This is very important. Okay, for the IC, to calculate the length of the curve for this equation, is it this equation? Can you see this? This equation is ds is a very obvious. First of all, you just write the ds. What is f prime x 2 to the dx. Therefore ds is what? You need to find out the equation here. Okay, you need to find out the equation, then you should able to calculate that. Okay, what is f? Okay, what is the f here? Simple. Y equals to 2x. What is dy? Dx. Dy dx is 2. Can you see that? Therefore dy dx here is 1 plus dy dx 2 dx. Therefore this combination I need to combine together. Is it my voice going down and down? Okay. Okay, the combination that I may get it here is a 4x to 3xy. This, when I substitute 2 here, get a 1 to 2 dx. Therefore I get a ds is, the ds is a square root of 5 dx. Okay, what is the range? Range is, if I use a dx base, is here 1 to the 0. Okay, a very the coverage is cover, then whether you can see all what I'm doing here. Okay, with that, can I calculate? Yes. Can I change this dy? Can. This is 1 0 4x. Okay, you can remove this to the you can bring it this to the front, but x 2x. Okay, the overall square root of 5 dx. Okay, please, I hope that you can solve this comfortably. Okay, let me show you this. Is 4x2 to okay 6x2. Therefore 6x2 by 3 is a 1 0. Okay, it's a 1 0. The solution that you will get here is a okay. Okay, the solutions. I hope that you got a new method. Then you already learned a new method here. Okay, so far we covered how many method? Method 4. Okay, now shall we proceed further? Proceed further to another one more method, which is parametric. Again, we already learned this anyway. Method number 5 is nothing new. Okay, nothing new. Although I call it this as a method 5, actually I'm using the parametrization. Okay, we are using parametrization. Okay, parametrization, as I introduced to you first, this is the work. Okay, I stand for the work. The work that we are referring for the curve, that's why we call it as IC. Okay, for the f x y z ds, we are combining the ds again. This is from method 4, right? This is method 4 that I introduced to you. Okay, now we change this method to parametric. Okay, parametric, this x represented by the gt. Okay, I put the ht. Okay, then the kt. Okay, for the ds here, therefore okay, x representation and ds. Okay, again I need to tt, ht, kt. Okay, ds is a parametric. Dx, dt, 2. Well, the formula look giant, but the solution quite fast. You can solve it, but depends on the problem. Okay, dt, dt. Okay, now if we mix x to the solution, therefore depends how do we handle this problem. Then it could be any combination. Okay, the gt can be any function of the t. The h is again is a function of the t. K is a different function of the t. In the normal cases, the t always will go for the 0 to t to the 1. But I am not going to fix this again. Okay, it's not going to fix, but normally the range for the t will be 0 to the 1. Okay, for the normal, it's a normal range for parametric normal. There can be some other different range unless they give you. Okay, what is the idea? What is the idea of this? Okay, when you take these three, can you get some visual understanding of this? The visual understanding here is quite complex in a way. Z, Y, X. There is a different way. There is movement here. This is an object. Okay, the object with the 3 different dimension. 3 different dimension. Therefore, I may say it's like this. Can I how to portray this? Okay. Okay, I'll do this. Don't. Okay. It's a kind of, I'm using like GT, calculating for the GT, AT, HT and KT, combination of these 3 moving on this line. okay, moving on this line. That means it's forming this line. Okay, therefore try to understand what is this logics of this about. Okay, let us start with the example. Without further ado, let me go for the example. Evaluate. Okay, evaluate here xy ds. Okay, this one is a gauss, but is a magnitude. Gauss is not a vector without direction, you know. That means this gauss is not a good one, which don't know the range, direction along the straight line. Along the straight line, C from the point A -2 1 to the point B 1 4. Okay, therefore imagine there are A -2 to the 1, B is 1 to 4. Okay, therefore how many ways to solve this? How many ways to handle this problem? Okay, now the first question, where is the equation? Where is the equation for this line? You don't have the line equation, right? Therefore again you may have two options. Okay, since it's a straight line, but remember, unless they mention to you, it's already clearly mentioned to you, this is a straight line. Therefore you can use a vector, or you can use your common form 5 mathematical calculation for the curve and straight line. You can find out the solutions. Okay, can I put this way? It's easier for me to. Okay, option 1, which basically we can use y equals to mx plus c. This is very simple. I think you all can calculate that lah. Okay, dy is I use a dx straight away, and therefore what is the ds? The calculation of the ds is straightforward. It's a dx to the dt, dy to the dt. How do I know this is a dt base? Okay, or you can use the parametric. Later I'll show you how to use the parametric here, but I prefer to use dy dx. That means here the ds, because I'm showing all these things because you know these formulas can be written in a various way. Okay, dy dx for the dx. Okay, I don't use dt. Later I'm going to calculate for the dt. I show you how to calculate dt, but now I can straight away use this. Okay, therefore it's a very straightforward. I can use this one. Okay, I just combine here. This is simple. Dy dx is okay. Dy dx is a 1, right? Therefore 1 plus 1 dx. Okay, combine together. Okay, the solutions here, which you will get here, the ds is 2 to the dx. Therefore the xy ds can be calculated based on the okay, what is the range that we are using here? One thing that you can take a notice here, there is no direction. Okay, we are not bothered anymore the directions here, but you are using, okay, low to the higher. Okay, Therefore you see 1 to negative 2 x plus 3 2 dx. Please solve. You will get negative 3 to 2. Okay. Okay, option 2. Option 2. In the option 2, we use vector line A to B. Is it A to the B? We don't know. Okay, is it moving up or moving down? But still we wanted to use a vector here. To the I use this as a RT, therefore I use A since it's a straight line. Okay, just now I use this as a straight line. This is for the straight line. Remember, this is for the straight line only we can use. Okay, therefore the calculations become negative 2i plus 1j. We're taking the coordinates only. Don't get panic here. We are taking negative 2i. This one is a 1j. Okay, therefore it's not that complex, right? Okay, we are adding t here. Okay, 1i plus 4j minus negative 2i plus 1j. And you solve this together. Place the t accordingly. Sorting. After sorting, you get a t to I, all I gather here. Okay, for the all j, t plus 1 j. Therefore, very obvious, this is a xti, this is yt j. And what is the range? The range is 0 t 1. How could this possible? This is RT, yeah? Therefore the RT can be calculated, the xt representing this, the yt representing this. Okay, can I start calculating this? Okay, possible for us to calculate the in this particular case we can calculate the method 3. Okay, I just use the fast method to calculate. Why am I introducing this? Just for the purpose of this, just to show you. Okay, dx dt 2 plus dy dt 2 dt. Again, some of you may say, sir, this is wasting our time. No, actually, okay, don't expect all the time you will see this kind of questions. Okay, some books, some different books or different questions may approach the problem all the way using vector. Okay, that's why I'm introducing this. Just some students is very helpful for the students to understand and to grasp these logics. Okay, when I try to change it this, which is I get a this is a 3, right? 3. Okay, please try to understand this is a xt. Okay, the xt is a 3t, right? Can I do the dx dt? Is a 3. Okay, for the y is a yt is equivalent to 3t plus 1. Okay, you will get a 3. Therefore the equation here 3 power 2 dt. Okay, therefore the ds here is become 2 square root of the 2 dt, right? 2 I take out a 3 here, then I get a 2. Okay, solved. The ds is something like that. Therefore, how to calculate the xy xy ds can be calculated based on the x is a representation of 3t, okay, integration 2 and 3t plus 1 3 square root of the 2 dt. Then you solve, you get the same results as this, negative 3 square root of 2 divided with the 2 beside here. Okay. Oh, a little bit small, seems too small for you to see. Okay, wow, I forgot to. Okay, I put it side by side, therefore you can see these questions, then you can it's the same answer. Okay, once you solve it, you will get the same answer. Okay, did you manage to? Okay, I bit slow down because I have my battery going to finish. Okay, then okay, now let me continue. Okay, let me continue for the battery method number 6. Okay, method 6. Method 6 is playing very important role. I hope that I can finish at least the method number 6. Okay, without any. Okay, I don't think so that I can able to. The battery might finish any time, but okay. But anyway, let me continue. Okay, the idea is something like this. A, we are moving towards a B. Okay, A, we may choose a various way to go to B. There are various methods to move to the B. Okay, I am choosing this. Okay, I am using maybe one of the way is okay, I use bicycle. Okay, I use bicycle. Okay, to go, or motorbike. Okay, this one I may use car. Okay, I may use car, and I may use various method here. I may use aeroplane. Okay, I may use aeroplane here. Okay, I call it this is a work C. I call it this is a work B. I call it this is a work A. Okay. There is one condition. I may use a cycle, or I walked, or whatever. Shouldn't be a problem. If A, the work equals to work B, work to the C, then if they can be a possible, we can calculate this. Okay, we can find out the work is equivalent. Okay, you may say, is it the same path? No, it's a different path. But when I calculate, I get it same. The work done by 3 different vehicles here, okay, will be same. Then I will call this as a path independent. This is a very dependent. Path independent. I want you to understand this same terms. Okay, path independent. Okay, or I will use the another term to address people will use this path independence. Okay, later we will use this similarly for the path independent. I'll tell you what is conservation and all these things. Okay, we call later for the conservative also. Or later we can prove this to be irrotational also. Okay, but most important things is path independent, the meaning of path independent. This is something very unique case. Okay, if there are two cases, if f is conservative in any in A, from A to B, in this case, then if I call it f is a conservative, then okay, then if I call it f is a conservative, then f equals to fdr is path independent between any 2 points A, B, or it could be or C, but as long as between any 2 points A, B, or it can be A, B lah. Maybe I'll put it here A and B. Okay, A and B. Between the A and B, there is no C here, but you imagine there is a, between the 2 point here, there is a path independent exists. F is, we call it as a conservative. Okay, therefore this topic, I put a star topic. This is a star, 3 star. Almost all the time, this is one of the most important evaluation questions. They would like to evaluate this. Okay, where we can see this kind of scenario, this is a thermodynamic questions. Okay, in a thermodynamic, we can see there is a path independent axis, in which case adiabatic. Okay, when we see this is a conservative, then I am not going to go too detail about this thermodynamic definition and etc., because we don't have time here to define all these things. But you will see this in the thermodynamic. Okay, path independent. The path independent, later I'll try to define back again in this. There are, previously we learned total, right? Total differential. The df can be defined as del f to the del x dx. Okay, you see everything is coming back. dy del f del z dz, which we can say this is mdx. Where did you learn this? N dy, and I call it this is a p dz. Okay, earlier we learned in our first order and second order, when we learned what you call exact and unexact. This one is totally related to that. Okay, therefore let me define to you this. This is very important definition. Okay, path independent or f is conservative if first exact. It is exact. If it is exact for the 2D. Okay, for the 2D means we can choose this. Okay, we already learned exact, right? The n d x, we already learned this before. Or if you use dz, it will be dp dy del n to the del z for the 2D base. Okay, or continuously I may able to write, but the most important, this is for 2D. For the 2D scenario, 2D means here again I repeat to you, it never involved either one of z or y or dx. Okay, therefore it's exact. We already learned this before. Okay, to find out how to find out the exact, whether the equation is exact or not, right? We already learned in the first semester. Okay, now if the case is exact, okay, if the case is exact, then for the 3D, this is for the 2D, right? For the 3D, this equation automatically, you can see it's become del f, okay, 0, and this is conservative, okay, conservative. Therefore, if this is a 0, we can write the whole equation I j k del x del y del z m n p equals to 0. What is this? What is this? This is curl f okay, curl f basically is equals to 0. Curl f is equals to 0. That's what you're seeing here, curl f. That means okay, how to calculate this? This is a very important that I wanted to stress to you. This is very, very important. Therefore, you can see del p, del y, del n, del z, I minus, okay, this, okay, del p, I, right? This one is del p, del n, okay, this one del p, del x, minus del m, del z, j, negative, plus, okay, this one del n, del x, okay, del n, del x, oh, the paper is not straight, huh? Del n, del z, minus del m, del y is k. If it is a 0, can you see this? You will get exact del p, del y equals to del n, del z. Why? Because it's a 0. This must be 0, this must be 0, this must be 0. Therefore, you can see del p, del x equals to del m, del z, or del n equals to del x equals to del m, del y. What is this? Exact. Okay, the exact. Therefore, it could be any one of these combinations, okay, but all must be fulfilled, all must be 0. If you can find out, this is what for the 3D, okay, for the 3D, this is for the 2D, this is for the 3D, okay. Therefore, this knowledge is the knowledge for the 3D. Therefore, can I call it this, okay, for the exact for 2D, maybe I call it this is number 2, okay, conservative, if it is this. What is this knowledge is about? This knowledge is saying rotational, okay. At least you can remember the word. If a path independent taking place is exact, okay, for the 2D, you check for the exact. If it is a 3D, we can say it's a conservative. Straight away you can check for the irrotational, okay. Therefore, you can see the curl is 0. Therefore, you can conclude I will show you the for the case is, again, in this particular case, if it is a conservation irrotational, is a 3D, Remember, the f is a determinant here. Why? It's a bit blur. Okay. Oh. Now adjusting the camera. Okay. This is 2D. Okay, for the 2D base. This exact is a 2D. For the 3D is a rotational method. Okay. Now, but the determinant is f. Remember, the f will determine the whole thing. Okay, let me show you the case for continuation. If the case is if f is a f1 I, f2 j, f3 k, the path is irrotational. Why irrotational? Is a path, we call it as a independent or conservative. All these terms referring to this one. Okay, for the case is f I j k del x del y. Okay, is a z f1 f2 f3, it should be 0. Okay, for the 3D concept, you can see this is a for 3D. But if the case is f equals to f1 I, f2 j, this will end up exact method. Okay, but we can still use the same method. I wanted to show you this because you can use irrotational method to check this as well. Okay, del y, this is del dz, but the function here k is 0, right? Therefore you can use f1 f2 0. Therefore the end, when you solve this problem, you get this overall 0, right? 0 calculating. Okay, just for the calculations, you see this one is a 0, you can see. Therefore the end, you will get the what do you call the calculations here. We able to say del f2 del x, okay, minus del f1 dy refer to k alone. Okay, okay, you try to solve and see, you will get it this. Okay, we are referring to the j because it's a f. This is equivalent to 0, then you will get exact f2 del x del f1 dy is exact. Exact is okay. Therefore I have already given steps for the 3D, and even you can use this for 2D. Okay, to calculate the from the rotational, how to calculate the exact. Okay, number 3, in order to solve this, you can see this is the most important things for the definition. If f is del f, there exists a nabla f where f is potential function. Okay, where in which case if F is rotational or path independent. Okay, they may use in the evaluation, they may use several terms. Okay, they may say it's a rotation, okay, rotational, path independent, or they may say it's a conservative. Okay, conservative. Okay. Therefore, in simple, what we learned, okay, number 6 is as a very challenging one. Again, as I say, I repeat, this is a very important for you to define the logics here. Therefore, you need to know 3 steps. Okay, I just stress again. Okay, so far I explained to you, just quick one. Okay, there is a path independent. There are 3 criteria to check. Okay, what are they? One is exact for